Share my desktop.
Those are the ones that I TA to. The ones I TA. Oh no, I would be dead. I would be dead. I would call out guys. Don't even question.
Okay, I'm gonna start up today's topic or today's lecture, and today we're not gonna really teach any new Python. We're going to basically apply what we have done in using ArcGIS for Python in a new area. We're going to talk about how we can run a script as a tool in Arc Toolbox. But to do this, I need to make sure that that the computers that you have are capable of doing this. Now, I think I asked this before, but on the coast, do you guys have have you ever run Python using what's called IDLE, or have you just been using Jupyter notebooks?
Jupyter.
Okay. All right. To do what we're going to do today, which is I'm going to start up ArcGIS Pro real quick here. Now we've demonstrated how you can write a tool in we've demonstrated how you can write Python in ArcGIS Pro. But this is going to be even a little bit different than that. So what I'm going to do is start up a new blank template in ArcGIS Pro. Okay, and then I'm going to save this somewhere. This is probably as good a spot as any if you just want to save it there. Or maybe I'll save it. I don't know if this will. I think I'm going to save it in. I'm going to save it in the directory I've been working in, so that it'll upload it to GitHub when I do a change. So George, that's in George courses. Yeah, where is that? George courses. There it is. SPA. And we're on week 5, and I'm going to put a new directory in here, and I'm going to call this new directory ArcGIS project. That way it'll upload, and you could download it if you wanted to. You have to change some of the paths. So I'm going to say that's the folder, and I'm just going to call this week 5 sample. So that's the name of the project. And just like, what happens when I create a new project actually in ArcGIS Pro?
It makes a new database, doesn't it?
It does. It makes a new database. Let's look on disk. I'm going to look on disk right here, an ArcGIS project. It creates a folder for the project. Yep. And inside of that, it creates a new geodatabase. Actually, I think Ashley said that, a new geodatabase. And it also creates a new project file. That's what APRX stands for. It's ArcGIS project. I don't know why the X stands for that, but that's what it is. And then finally, it actually creates a toolbox, a TBX file for you. Okay. And you can see that file if you go under the catalog view. You can see that under toolboxes. This is the toolbox that is just created for you, toolbox file. You can build models and put them in that toolbox file. Kind of covered that in some of my other classes. So if I were to go new model, it would allow me to build a model right inside that tool. Okay. I'm going to leave that there for a second, but I'm not actually going to build anything yet. But I am going to demonstrate something from here in a second. we're not in a second, but during today's class. But it also allows us to say, I want to build a new script. Okay, creates a new script in the toolbox. Now, what's interesting here is if you say new script, then it's actually going to ask us for where the script is. So it's kind of what would I say? I don't know if I'd call it new script. Really, what you're doing is you're connecting an existing script to a tool. That's a better way to put it. So this is where the script file needs to be. In other words, it's asking you to find a script, whether that's a BAT file, a COM file, an EXE file, a PI file, or an R file. So you actually don't have to write the scripts in Python, but they need to be one of these extensions: BAT, COM, EXE, PI, or R. R is another scripting language that's specifically built for doing statistics. Okay. These other ones aren't tied to computer programming languages at all. BAT, COM, EXE, those are all Windows binary files for, well, actually a BAT is a command line executable, a batch file. .com and EXE are both compiled executable files for Windows. So you could write your script in whatever language you want. If it can compile to be run in Windows, you can attach it. It has to have some abilities though, whether it's programmed in Python or programmed in whatever. It needs to run at the command line. Okay, so what do I mean by that? Here's the command prompt right here. You got the command prompt. And if I type the word Python right here, it says Python's not recognized as an internal external command. But if I find Python on disk, where was that? I forgot where I put it. I think we covered that the first week. But actually, if I create a Jupyter notebook, I'll be able to see where it starts it. Jupyter notebook. So Jupyter is pulling up here. In this in this window, this black window that popped up, I can see where it's running Python. Okay, so it's running it in C, program files, ArcGIS, ArcGIS Pro, bin, Python, in ends, whatever. Okay, so I'm going to copy out this portion of that text. C, program files, ArcGIS Pro, bin, Python. Actually, I'm only going to copy to Python. And I'm going to copy that into Windows Explorer. Whoops. So here is that Python directory. And if I go, I think it says in, and then here, I'm trying to find there it is, the Python executable. Python.exe is in this directory right here, plus it's called Python.exe. So if I go back to my command prompt right here, I have to put this all in quotes because there's a space. It's one reason why I hate spaces. I'll just cd down to it. So now I cd'd, which means change directory, down into this folder. And if I type in dir, I can see all of the files that are in that folder, including the Python executable, which is right there, python.exe. So now if I type Python, I will get to the Python command prompt. Okay, and I can start typing Python commands. 6, B plus 7, A plus B, 13. Sorry. I had to sneeze. Thought I had to sneeze, but I didn't. Okay, so I'm at the Python interpreter. Okay. I'm going to exit out of here. Exit with quotes. Now I'm outside of it. And now I can write a Python script and execute it from this command, from this command line here, if I gave it the path to the Python script. All right, how to get to that? Let's find. Well, let's actually write a Python script. That's where it was. Okay. This is a Python script. Okay, so we can write a Python script in any text editor. Now, did we find out if you guys had Notepad++ down there? Do you guys have? Yeah. Do you just have Notepad?
I think it's just Notepad. Yeah.
Okay, so let's open up Notepad so that everybody will be the same. Let's see if I can. I'm going to zoom in a little bit. And I'm just gonna write a very simple. I'll write a very simple script. A equals 7, B equals 5, and I'm just gonna write print A plus B. Okay. So this script should print what? Right. And I'm gonna save this. I'll save this in this week's folder, and I'm going to change the extension so that it's just going to be called simple.py. I'm going to save it in this week's folder. Save it right there. Okay. So now I have it there as a script. Okay. Then, if I go back to my command prompt, I can type in Python, and then I give it the script I want it to run. So I have to put the whole path to that script. So let's find that because it's pretty long. C users George courses SPA 5 simple.py. Okay. So copy that, put it over here, and it has to be in quotes. No, it doesn't have to be in quotes because there's no spaces. Good. M5/simple.py. So what we're doing is telling Python to run this script. Python is going to run that script. I'm going to press enter, and look, it printed 12. It worked. It didn't actually start Python like in the interactive window. That's what happens if you just write Python. But if you put Python in the name of a script, it will then it'll then run the script, and in this case it printed the result 12. Okay. See how it did that? Okay, now something else that's useful is the ability to pass values into the script, kind of like the script is a function, but we want to pass values into the script. So in order to do that, we have to import a module. Python will allow us to import a module. We can say import sys. Sys is a module that stands for system. And if we import sys, we can grab all of the information that came in with the command line. So here, let's look at the help for sys. Python sys. So sys.argv will be all the arguments. They're called arguments, the command line arguments. So if we say that A is equal to sys.arg v1. Actually, let me define define arguments first. Okay. So if I go back over to my window here and I type in Python, if you just press the up button, you'll see everything. If I put something else on this line, 5 and 7, these are all the arguments. So Python is the name of the program that's going to execute. This is the name of the script that's going to execute. This is actually the first argument. So that's the first argument. The second argument is 5. The third argument is 7, and so on. We could put in as many arguments as we want. Those would all count as command line arguments. We could also put in hello as another argument. Or I could put in my name or a name. I'm just going to put in Bob. Okay. So Bob is the 1, 2, 3, 4. It's the fourth command line argument. Okay. One thing about command line arguments is they always come into Python as strings. And so you have to actually tell it if you want them to be something else. So when we say sys.argv1, it's 0-based, by the way. So sys.argv1 is going to be the second. It'll be 5. And sys.argv2 will be 7. So now if I save this and run this, what's that? It'll be 57 because, why is it 57 and not, yeah, everything comes in as strings. Exactly. So 5 plus 7 string-wise is just concatenating those two strings together. So it's saying 5 plus 7, 57, meaning that I'm putting the 5 next to the 7. So if I actually want this to do the right thing, what should I do to change this? Yeah, put int here, or even float would actually work. It would still give me the right answer. So then I could run this, and I get 12. I get 12.0 because I made it a float. So now those have come in off of the command line. So you could basically you can write a script that takes information in and runs something and returns a result. In other words, now you have the power to write a script that has input parameters or arguments. Arguments, parameters, those are often used interchangeably. But you can see how this is like a function. Just like a function, what values did we pass in? 5 and 7. And we got a result. It returned a value to the user on the screen, right, using the print statement. This functionality is what allows our toolbox to use a script. So what happens when you create your toolbox, anything you want to pass in is eventually going to be a command line argument. You don't get to see it when it actually runs, but you're going to pass everything in as everything gets turned into a string, and so your script needs to accept everything that comes in and to change it, and then there's actually a special way that handles returning the output back to the user. Okay, and that's also returned as a string, but that's one of the things that we'll learn about today. Okay, so we could, yeah.
You would call 57 to be like 5, 7, 5, 7. So look at it this, look at it 57, it's a string 5, 7. There's a way that you talking about 5, 6, 7. Somewhere between those so that it appears, when you look at it, it looks like a number, but actually it's a string. When you get it before the INT, before the INT argument, someone came back and said 57, but it's really 5 and 7, correct?
Yeah, but there's no way to report to the user which one it is. You made a mistake. Like, in other words, if it prints 57, I made a mistake. I made a mistake in my coding, but there's no way for me to tell the user that it's anything. Yeah, it's a 5 and 7. You're right. It is just a 5 and a 7 next to each other.
Could you put a 5 and a comma 7 on there? And then
I mean, certainly you could. Like, you could say print A, comma B, but then it's not going to add them together. Yeah, my point is, you have to decide what you want to tell the user. If you want to tell the user these are two different numbers, then you have to format the output to look like two different numbers. If you want to tell the user that that they should be added together, then you need to add them together. All right. Let's see what this is yelling at me about. Okay. All right. So let's turn our script into something that runs in ArcGIS. Okay. So our script is pretty. I don't know. I would say kind of lame right now, but it will actually work as a script inside of ArcGIS. Okay. So what we could do is go back to ArcGIS Pro, and we could choose the script file that I just created, which is in back up here. I go see users, George. Sorry, did somebody ask a question? I still didn't hear. Oh, okay. So I'll cancel out of this. Cancel out of that. So this is back in week 5. Like if you just go to the toolboxes in the catalog pane, you right click and say you want to create a new script. This should really be called a new script tool, which is what the help says. Like if you hover over it, it says create a new script tool. It doesn't actually create a script for you. You need to already have a script to point it to. So I'm going to say a new script, and then you have to point it to the script. So that's where I go see users, George. This is where I put it. You could put it wherever you want. Courses. I put courses.
And you're just uploading the notepad document, right? Or are you actually uploading the command screen document?
I'm going to navigate to the Python file, which I thought was in here. Maybe I have to hit refresh. Yeah, there it is, simple.py. It's the Python script, and it's not actually gonna make a copy of it. I'm just pointing to it, so I can update it and it'll change it. So now I put the path right there to the Python file that I just created. It does say I can import the script, which I guess means that it'll run. It'll make a copy of it. I'm going to say store tool with relative path. That way I can update it and change it rather than rather than making a copy that I can't change. This might be something that's good after, yeah, so then it's embedded. I don't want to do that. So that actually make a copy of it. I want to keep changing it and making it better in this case. So I think it's good while it's still in development to say store tool with relative paths, not import script. And then if you ever want to just import it, it'll actually make it part of the toolbox, and you can share it with somebody else. And then they can no longer, well, actually, unless you set a password, they can still see it. But they don't have to worry about copying it separately at that point. By the way, if you want to hit this, learn about more about script tools. This is the help on the subject, which I guess would be good to put in the I guess I closed it. I'll put a link to that in the lecture later on. But yeah, that's the help. Okay, so I'm going to not check this, make sure this is checked, and then if I hit OK, it will run that script. The problem is that it won't pass anything in when it runs. So watch when I hit OK here. I can always come back and edit it, so I'm going to hit OK. And then now when I try to run the script, there's no parameters. There's nothing to feed it. And actually, if I try to run this, it's going to fail because it's going to try to find those that additional data. It's going to try to find those additional tools. So now it's trying to run it. If I look at it, it says it failed. It failed in line 4 because it couldn't find sys.argv1 because I didn't pass anything in to the parameters. I didn't pass anything in. In other words, it just tried to run this. It'd be like the equivalent of this line right here, where it didn't try to pass in any command line parameters, but now I'm asking for command line parameters, and so it's saying, oh, it didn't work right. Okay. All right, so let's go back, and I'm going to go back to the catalog, and I'm going to right-click, and I'm going to say properties. If I say edit, it will actually try to open the script for me. See, if I say edit, it'll actually try to open the script. It's kind of cool. By the way, anybody following along, what if you guys right-click and say edit? What does it do?
I'm gonna watch everything you go on.
Okay. Just
Yeah, I kind of got lost, so I'm just watching it this way.
okay.
You did your screen. I can't. Yeah, we can't read the text on your notepad.
On here, you can't read the text.
You can read it now, okay? You got great background, you see it.
I don't know if I have the option. Let's see, configure IDLE.
Just highlight it for a moment.
I would just make the text bigger, it's still functional. You can change the font of the text.
There's bigger. I wish there was a dark. Is that a little bit better?
Yeah.
Okay, so this is the script I'm working from. Now this actually came up because I right-clicked here on the script tool and said edit. And now it'll bring it up. This actually is a notepad. This is a Python, a very, very simple Python IDE. In other words, it's an integrated development environment for Python, but it's very, very simple. All it does is help you because it'll sense when you create a new function. It'll sense that it'll see how it indented that automatically. It does that, plus it does the coloring. But other than that, it really doesn't do much. But Notepad here doesn't even do any of that. Let's see if I can view. I can make the font bigger, but I don't know if I can if I can make the colors any different. Okay, so see, it's the same script. It's opening in both places. Oops. When you shake your when you shake something in Windows, it puts everything else away. Okay. All right. So see how it's asking for these two parameters. I'm going to assume. I hope that this will pop up. I was looking for this. I don't know where this executable exists on disk, but that's ideally one we want to edit in. Is this IDL? This is called IDLE. Okay. I can even actually run it from right here. Of course, if I try to run it from here, I'm going to get this error that the list index is out of range too, because it doesn't have the ability to grab sys.argv1. It's like, what? That doesn't exist. It's out of range. You don't have a sys.argv1. Okay. All right. So to change that, I can go back in and say properties, and then go under parameters. These are the values that will be pushed in to the final result. They'll be pushed into the script as the script tool parameters in order. So see how it says define script tool parameters? They'll be pushed in here, 5, 7, Bob. They'll be pushed in that order. So I need to provide it a label. A label is just what the user sees that you're going to call it. So I could call this, first number. Okay. And then the name is a computer readable version of that. So it's just going to put an underscore. And second number, and then name. And now, under data type here, this is important, but it's not as important as you think. Remember how I said that these parameters are always passed as strings? That's still true. So you think, well, they're always going to be strings, so why should I change it? Well, this allows you to tell the user that it needs to be some other type. In other words, if I specify that this needs to be a number, when I run it, I need to specify a certain type of number. So I've got a long, I think that's all I have for integer. I got a long or I got a double. Do I have a float? Nope. So I got a long. So there I can say long and say this one needs to be a long. A long stands for a long integer. So now I'm saying that the user has to enter a long integer. They can't enter anything else. I'm going to hit OK here for a second and show you what these do. Now when I try to run the script tool, do you see how I have to enter the first number, the second number, and the name? Those are going to become, when it passes them off, they're going to become sys.argv1 and 2 and whatever. See, when I hit 4, 5, Bob, and hit run, now it's actually run, and it ran. It completed. It's not read anymore. Okay. Now there's no indication that the value is going to get passed back to the user. So that's something we still need to learn, because the user doesn't get to see any print statements. Okay. So we're still going to learn how to get a value back to the user, because that's going to take some extra coding. Not much. It's a pretty simple process. But now we've successfully run it, and in the computer's brain, it's actually doing everything that's in the script. It ran the script, it completed it, it used that 4 and 5, we were able to pass it in, and it ran it. So now I'm going to go back to catalog, and I'm going to hit properties again, and talk about what these other things mean, and then we'll talk about actually returning the result back to the user. Okay, so I told you what the data type is. You can actually specify that you want them to enter a feature class. What's a feature class in ArcGIS lingo?
Anything like a shapefile or anything.
Right. It's the general term for a vector data layer. So it'll be a shapefile, a file geodatabase, point line or polygon layer, or an old ArcInfo, a point line or polygon layer, any of those. See, now if I hit OK and I try to run this script, it's going to ask me to find a feature class. See how it's, see, it prompts the user for the right thing. So that's kind of neat, is that, you know, the user gets to be told, oh, you're trying to find a feature class. So now I can only choose feature classes on disk. I'd have to go find one because there's not one in here yet. Okay. So that's how you pass something off to the user. All right. So we got feature classes. I'm going to change this back to long for now. Long. You can even specify that you want them to enter multiple feature classes or multiple numbers. In this case, right now I have it set for multiple numbers. So now if I go back over to here and I hit open, it's going to ask me for a bunch of numbers. I can just keep pressing enter and enter more numbers. I don't want to enter that number. Okay. All right, that's not really going to work. We don't want that. So basically, it's going to pass that in as a list. Okay. Long. Oops, I'm going to change that back from multiple values. So that's what the data type does. Now the type is simple. It's either required, optional, or derived. Now what that means, you guys can figure out what required means, right? In other words, the user has to enter it. It actually won't allow you to run it until you filled in the value there. You can't press run. You can press run if you don't fill out an optional value, but you can't if you've only hit required. Now what derived means is that you don't want the user to specify at all. It's going to be something that's returned back to the user. Derived, see when I change that to derive, it automatically changed that to output. So if you use derived, it'll change it to output. Sorry, was there a question?
So the output is derived from some other operation to give the user.
Right. The direction being output means that the user doesn't get to specify what's going to go in that value. It's going to be determined by the script itself. The script itself is going to create a value and it's going to put it there. Does that make sense?
Yes.
Hey, Dr. Raver.
Yeah.
When I run mine, it just says that the script associated with this tool does not exist, and it fails to execute.
Okay. So like, what did you put in here? Did you manually type
Same
something?
thing, except it's to my users, and it's my student ID, and then it's to the text file.
Okay. It's to a text file, not to the PY.
Yeah, that's probably. I saved it as a text file. Okay, I'll try that.
And you're sure that it exists at that location?
Yes, sir.
Okay. Yep. And
Yours is a Python script, is a text file.
right. Yeah, you have to save it as a. Make sure you save it as a Python script. You don't have to do anything special. Just choose all files when you save it. when you go to save it, make sure you choose under drop down, you choose all files, and then you name it something and put .py. All right, so then you can choose to say that you want it to be an output, but still let them specify what the value is. In this case, it'd be something like a file name. You want them to specify where to put it, okay? But it's still going to be something that is created during the process. That's an output. So let's see, like let's put another one in here called like file or output outlayer. Let's call it that for now. So if outlayer is going to be a feature class, in other words, we're going to create a new, we're going to do a buffer. Okay, we could do a buffer. Then if we say that it is input and required, I'm going to say OK here for a second. If we say that it's input required, it's going to be asking me to search, and I'm going to have a valid location and a valid file to get it before I can hit OK. See how OK is grayed out? Okay. But if my script's going to create it, let's go back to here. If my script's going to create it, I want to say output. Watch how that changes what happens. Now, when I say outlayer and I hit this little guy, I'm allowed to type something like, you know, pizza, or I'll just say out buffer, and hit save. Now I'm allowed to specify something that doesn't exist yet, because the script is going to know to put the output in that location. So I have to specify, in my script, I have to write the output to that location. So this path is still going to be an input parameter to my text, and I can use that to save out my my result to that location. Okay, so before we get there, though, I'm gonna delete this for now. This outlayer. Okay, so we just have our first, second, name. We can also change a few other things. These other ones aren't necessary. I don't use many of them much, except for the default. Sometimes I do use the default. So the default allows you to put a number there so that they don't actually have to enter something. So if I entered 6 and 12 and hit OK here, now when I try to run the script, these 6 and 12 values are the defaults. That way, there's a value there for them to work with right from the beginning. So that's not necessary. Filter, you can actually say, oh, I only want people to enter a number between 1 and 10. So, you know, here 1, 10, say OK. Now if I go try to run the script, and I say I will change this number to 12, see how that actually shows up there? It's outside of the range. The range is 1 to 10 that they specified. So if these represented a month or something, you could say 1 to 12, and you'd force them to enter a value between 1 and 12. So that's how that could get useful. So a lot of these are for helping the user choose the right value. That way you don't have to do as much error checking in your script, right? You don't have to say, if the value is less than 12, greater than 1, we're going to do something crazy, or we're going to tell the user that's not right. This way, they even before they start running the script, ArcGIS does the checking for you. All right, validation. Oh, sorry. You're gonna ask a question?
So you will have to know that you don't want them to go outside those parameters so that, um, it's easier to find the error by also the program and also the user, because you're both doing the same shit. If you didn't know and have an unlimited range or whatever, you'd never find the error, because they won't have anything to, trap it and reveal it to the user.
Right. Well, the user probably wouldn't have any idea. You'd probably have an idea. Like if they entered 13 and it was trying to find a month, then you might have an idea why it failed, but the user would be like, "What?"
But if we don't put that in there, you'll be searching for what the problem is. Even the programmer needs to have something to trap it so that he can know, because you have 15 or 20 different scripts. And he'll just be booked all the time if you don't put that trap in there.
Yes. Yeah. I mean, you can put some try statements in to try to figure it out, but that way will work a little bit better. Yep, and then validation is for if you want a really complicated script. Basically, what validation does is it'll run a script every time somebody does something like change the parameters, and it'll check for errors. I don't do this a whole lot. Most straightforward scripts don't need complicated validation to work right. The built-in validation of just filling this out well works well enough. Okay.
Well, Phil, you have to validate always because you don't see the code running. So that's why you always validate to make sure that it clears out everything, right?
Yeah, this does a lot of validation for you already. Like if you could specify a range, you could specify default values, you could specify what data types they need to be when they come in. So there's a lot of validation that already happens. Okay, but if you had a really complicated validation thing, then you would use validation, but I don't often use it. Okay. So, all right. So now that we've got our thing ready and it's providing the longs, it's providing two numbers, we want to change our script. I'm going to say okay here. We want to change our script so that it actually returns a value to the user, to the end user. Okay, and to do that, we need to look at. There's some helper functions in ArcPy that are specifically built to work with script tools. Okay, and here I'll just show them here. So they're called ArcPy get parameters as text and set parameter as text. So ArcPy.get parameter as text and set parameter as text. So these two are the most important ones. They're going to allow you to get the values out. And actually, what they're doing is just wrapping the sys.argv up. And so we no longer need to actually import sys. We need to import ArcPy. And then instead of saying sys.argv1, we need to say get parameter. Oh, sorry, I'm on set parameter. Back to get parameter. We need to say get parameter as text, and it will allow us to. And by the way, these are now the get parameter as text is 0 based, and it doesn't start with the script. So you need to go to 0 instead of going to 1. So ArcPy.get parameter as text 0 returns the first parameter. And argpy.getParameter 1 returns the second parameter. See that? So 0 and 1. So now this script should work exactly like the other script. Let's see if it still runs in ArcGIS Pro. Yep, still runs, still successfully ran, but we still didn't get a result. Okay. If we want to get a result, we need to actually set the parameter of an output variable. And so we need to run set parameter as text. Set parameter as text will allow us to return a value out. So I'm going to say here's my script. I'm going to say argpy.setParameter as text, and I'm going to assign the value, the third one, a value of, let's just say, let's say C equals A plus B, and then return C. Okay. So sorry, second one. So now it's going to take that value 0, 1, and 2 and return the value C. So C should be equal to whatever we put in to A plus B. So I have to save this. And then I go back to here. Now if I run this, it should probably fail because, oh, it didn't fail, but right now there's no value ready to accept it. See how parameter number 2 is the name, but it's not actually going to change the name because it's an input parameter. We need to change it so that it's an output parameter, and then we'll be able to see the result there.
Mine failed.
Yours failed totally? Did it fail? Did it ever work?
Yeah, it worked prior to those changes.
Okay. All right. Well, let's look at it. What's that?
Yeah, I'm just gonna edit it. Make sure I saved everything correctly.
So what I'm going to do is modify my script here so that I can make this, I'm just going to call this answer. And make this a derived value, output derived. So now it's going to get the result. So now if I try to run this, view details, now see how answer is 18, which is the right answer. 6 plus 12 is 18. So it ran, and I provided the result back to the user. It might be useful to, if you're fine with it, we could look at your script, and I could see what's wrong. If you want to do that, if you want to send it to me.
Okay.
Or are you in another way to do this? You can send it by email. That's fine. You could join this. Well, it's probably easier just to send it by email. You can send it through chat and Skype, but let's just do it by email. Man, got tons of emails. All right, anything coming through there? Did you send that yet?
I just sent it. I did notice that, and I don't know if this matters or not. So on your screen, whenever you're editing, your import is highlighted as if like, or is that just,
That's just because I'm using IDLE and you're using.
okay, yeah, gotcha. You can't read the red.
That's commented out now.
Uh,
That's my code. Oops, I ran it from here, which I shouldn't have run it. Okay, so I'm gonna run it from here. So script failed. Is this what you got?
yeah.
Good. So we're in the right place. So it says error in setting parameter as text. So that's where the error occurred, was in the set parameter as text right there. Oh, because this says 3 and there's no third parameter. Maybe on yours there is, but on mine I only have, well, there's a third parameter, but this is 0, this is 1, and then the other one is the third one is really indexed as 2. So if I change this to 2 and I run it, now it ran, and that's the result. So you just need to change that 3 to a 2. See what I'm saying?
Yep, that ran.
Awesome. All right,
So is yours outputting an answer, or are you going to have to go look at like your geoprocessing history to see the answer? So where is, like how you enter your numbers and it runs and it says successful, like where is the output?
the output's right here. Yes, it outputs it to the geoprocessing window.
I see, yeah.
Exactly.
Thanks.
No problem. Now, in reality, I actually, the way I like to develop these tools is in a two-step process. First, I get it to work as a script. Okay? So I develop it first as a script, and then I put it in here. But what you have to think is, how am I going to develop this as a script? And so oftentimes the way I actually do this is, you said the red doesn't work really well. For comments, I'm going to make it choose color for, yeah, let's make it, I'll just make it just like a pink instead of, so that way it'll show out. Okay, so my comment here is going to be set up input parameters, and so I'm going to say, yeah, that's where I do this part. This is the general sense how I'd write a script that I was going to turn into a script tool. Write any and logic here, and then finally return values out to user. So this is the way I'd set it up. And the reason that I can do that is, the reason that I would do it that way is so that if I'm just writing it to test and to run, I can actually comment out these lines, okay, and then comment out that, and just say A is equal to, A is equal to 3, B is equal to 7. These are like my test values. I could even say something like comment out for testing, or I could actually put these above and not even comment those out. See now, if I, and I also could just put a print statement here, because print statements don't hurt you at all. I gotta put that in quotes. Print statements don't hurt you at all. So if I ran this, it runs, and I could test it. See, now it's 10. I can test it, but then I just need to comment out these lines, and I'm all set. Now I can run it again over here, and it works. I need to comment out this line, uncomment out that line too. See how it didn't put the answer there? So I need that line for it to get that answer fed out back out to the user. So I can basically write the whole entire script, test it a few times, and then make it into a script tool. But in order to do that, I need to have all the input variables at the top. In other words, anything I'm going to let the user change, I need to put it at the top so it's easy to comment in and comment out. And then anything I'm going to return to the user, very bottom also, so I can change that easier. That often, almost always is at the bottom already, so it's not that hard. But sometimes people will start writing their script. Even if it's not that complicated of a script, they'll start writing it and they'll realize, oh, okay, this is where I need to get parameter 3. This is where I need to get parameter 4. Well, if you just push all that stuff to the top, gathering your parameters, and then writing them the way that you should write them, and then getting the result, it's easier to debug. So we will do that. In fact, what I plan to do is take a simple version of what we did last week. So even though we didn't get to talk about that in the lab, we can talk about doing that and then actually implement that here as part of the today's lesson. See how it doesn't hurt to have these. I can put a comment here, say these are for testing. Comment out the parameter lines below for testing. Doesn't help to define those. Doesn't hurt to define those here and then define them here, because they'll get overwritten here. All right. So that's a script tool, and so far it's just returned out numbers. And there's a few other things in the script tools. Oops. There's a few other of these script helper things. We've got we can actually get the argument count, which isn't super useful except for if you want to find out if there's enough arguments that are correct. And then there's also some messaging abilities, messaging and error handling. So these methods are for communicating information back out to the user. You can actually add errors, your own custom errors. You could say, like for example, if we didn't check is the value between 1 and 12, we could return an error out to the user and say, you entered 13, that's not a valid month in an error. So if I click on that, you can see how you could write add error as that feature class doesn't have any features. So in other words, if they gave you a feature class, you could check to see how many features there were in a feature class, which we haven't really discussed yet, but that is something we'll get to in this class. Then you could return to the user and say, I know you specified a layer just like I told you to, but it doesn't have any information. The layer is empty. That feature class is empty. And that's what that would do. Okay. Probably the one that I use the most often, because especially in debugging, is that I want to add a message. Okay, I want to add a message. This is the equivalent of a print statement. This will allow the user to see in the geoprocessing window any message that you want to feed it, to feed the user. So here's add message. So I'm going to copy that in, and I'm going to put this right under the print statement. See how it says arcby.add message? Okay. Now, did we talk about this format function in this class? I know the book author introduced it, but I don't think I talked about it. But it is kind of useful sometimes. Format is a string function. So in other words, you feed it a string, and what format does is that it allows you to put in placeholders that are delineated by squiggly brackets. A little bit sidetracked, but let's see here. Here, I can, for our purposes, I'll change this a little bit. 0 plus. Actually, I'll write this all in text. All right, so what this does, what the format operator does, is it takes A, B, and C, and one more thing I need to do. What it does is it takes A, B, and C, and it's a tuple. So it takes this tuple in here, and so it takes the first element of that tuple, and it puts it in squiggly bracket 0, squiggly bracket. The second element of the tuple, it sticks it in squiggly bracket 1, squiggly bracket. And the third element, it sticks it into here. And it returns a string that has that value. Okay. So what this will say is, in this case, it would be 3 plus 7 is 10. So that's what it would print on your screen. We could have done this without that fancy formatter. We could have just done this. This is an equivalent statement. I could have written str, whoops, str a plus str b plus a plus, and then just get rid of the format operator. Okay. So those are equivalent statements. You still need a closing parenthesis there, right? But and this is a more confusing statement, right? But it doesn't require a special function. So what we're doing there is saying A, and we're using string concatenation plus space plus. Okay. So they're the same thing. There are two different ways to write it, but it's doing the exact same thing. So I'm gonna file save this, and then run this over here, and we'll see how different it is. I might have to actually X this out and reopen it to get it to work. Yep. All right. So now you see how when I highlight over that, it printed those lines. It added those lines as messages. See how it added the 6 plus 12 is 18. It added it twice. It added it once for this line and once for that line. I was just showing you that those lines were equivalent. So there's just a fancier way. Like, what if you want to get text into a string? Well, you can do it this way, which is kind of the old way, or you can use the format function, which is a new way to do it, but requires you to do it. This has several advantages, though. One of the advantages is that it doesn't even matter what these values are. If they're strings, if they're floats, if they're integers, whatever they are, it will try to convert them to strings automatically. This one requires that you actually convert them to strings explicitly. Okay. So those are equivalent statements. That's a demonstration of add messages. What if we made this one add error? Let's see what happens. Okay, we're going to go, this one's add error. Add error has almost the same, all you need to do is give it an explanation. So now you have to close this to get it to work right. Open it. Did I save it? No, I hadn't saved it yet. Now I'm going to run it. It says it failed. Okay? So all it did was turn that script in, and then it caused it to fail. Anytime you add an error, it automatically causes that script to fail. So maybe I should, I'm going to comment this out, make this a message since it does the same thing, and then just write arcpy dot add error. Sorry, it failed. Now if I run this guy, it prints, sorry, it failed. It's not a great reason for failing, but it will fail if you just tell it it failed. So I'm going to comment that out, and then I'll put a comment before it.
Could you keep it on your text for just 1 second, please?
Keep it on this screen?
Yes, sir, if you don't mind.
Sure. If you add an error, it will fail. And return the string as red text to G. Oops. Let me make that a little bit bigger. All right. All right, so you can also add a warning, which will show up as yellow text. I mean, there's a few other ones in there, but those are the big ones: add error, add message, and add warning. So sometimes, like you might want to check and see, it might still work. Like let's say your tool is going to buffer something, and you might want to check and see if there's any features in there. And if there aren't any features, it's going to warn you. Or maybe a better one would be it's going to buffer and they don't have a projection assigned. And so you could warn the user, hey, I'm going to be doing buffers. Without a projection assigned, the buffer could get kind of crazy because we don't know what unit the units are in. So make sure you understand what units your data is in. Okay, there's all sorts of reasons why you might want to add a warning message, but that's what it does. Well, we could just do this. If a equals 0, gp.add warning, and say anything plus 0 is the same number. So now if I run this, file save, I go back to ArcGIS Pro, And if A is equal to 0 and I run it, oh, let's make B, because we already said B could not be, we already said A has to be between 1 and 12. 0, run. See how it says completed with warnings? If I highlight over it, now it says anything plus 0 is the same number. It just tells me it's just informative, but it kind of says to the user quickly, hey, you got a problem with your values. All right, let's go ahead and I know it's slightly earlier than we usually take a break, but I think this is a good breaking point because next we'll actually implement this with doing an ArcGIS process rather than just adding two numbers together. So let's take why don't we do about a little bit over a 12-minute break. So we'll come back at 5 minutes past the hour. All right. I'm going to stop the recording for now.